Definitely.
Yeah, Levi's has no value. What? Your phone adds no value to this. You could probably trade that. It's like an 8. Are you kidding? Yeah, it still adds no value. That's like at least 500, 400 bucks.
No.
You'd be lucky to get like 200 out of it.
Mr. Laman, did you post the flyer?
No, because it's just examples, so you won't need to take like a crazy amount of notes.
Ooh,
How much does it get in?
Well, you'll see. There's not any.
What are you saying?
You're kind of scared.
Okay, so today we are looking at solving these exponential and logarithmic. We ready? Ready to roll? All right. We're looking at solving all these equations that we've looked at. Now, we're not really adding any new rules, okay? We're just using the rules that we've learned, and now we're going to solve equations and solve for x. So we don't have a warm-up. Pretty much what we're going to do is look through, I think I have 5 examples written down. 1, 2, 3. Oh, 6 examples. 6 different examples of types of problems that you'll need to know how to solve. One thing that I do want to point out before we get started. Where's today's lesson? The only type of like notes that they take or that they show us. Come on, time to lock in. If we have exponents and they are of the same base, what are we allowed to do? Do you guys remember? Well, like, we have 3x equals 3 to the 2x plus 4. What are we allowed to do, Faith?
Can we do it like log base 3 and then
Yeah, I mean, we would log both sides, base 3, and essentially what would happen is we would get rid of those bases, right? We would get rid of those 3's. So one rule that we need to just be aware of going into everything is that if we have exponents and we get them to have the same base, then we can just bring the exponents down and solve from there. Okay? That's like one only notes type of thing. Well, that's 1 and 2. Okay. The second one. We had a problem like this. What would x have to be? Yeah, x would have to be 7. And what we didn't talk about it, but what you did is just drop the logarithm, right? So the second rule that we look at, if we have logarithms that are set equal to each other, and if they have the same base, we can just drop the logarithm.
it's kind of logic too, just if x
Right, exactly. Yep. So those are the 2 rules that we need to know that I think we already knew, but just haven't clearly defined. So that's what we're doing today. We're solving exponential equations, so we're going to be working with e to the something, and we're solving logarithmic equations and some inequalities, which really doesn't change a whole lot. So this is what our lesson is going to look like today. It's just 6 different examples that I would like to talk through. If we look at letter A, we have 100 to the x equals 1/10 to the x minus 3. Of those 2 rules we looked at, which one do we think we would want to apply here? I mean, how do we even begin to start to try to solve this? Any ideas? What could be a potential first step, or what would we try to do?
Log each side.
We could log each side. Right. We have different bases, right? So that might cause an issue. Would it be possible to get these exponent bases to be the same? To rewrite these bases in such a way that they are the same? Is that even possible?
Yeah.
I think it's possible. So what if we went like this? Wouldn't you what? What happens if we were to raise this 1/10 to a negative exponent? What would happen then? How would we like simplify that? Right. We'd flip it, right? If you have just x to the negative 1, we flip it. If we had 1 over x to the negative 1, we just flip it. So the same thing would apply here. So if we want to rewrite each of these to have a base of 10, then we could do that, couldn't we? I think so.
Well, if you take 100 and put it to the negative 1 power, it gets you 0.01.
Right, so we could go the other way too, right? We could rewrite 100 to be to the negative, we'd want to write it to the negative 2. But we could go the other way as well. But let's say if we had would these be the same bases? Think about it. Yeah, it would be. Because 1/10 to the negative 1 would just be 10. So if we can rewrite these, and this is probably a more complicated, not probably, this is a more complicated example than what we would typically see. Oops, I'm sorry. This would be 10. This is a more complicated example than what you'll see on the homework. But the point is that when we get the same bases here, then we can drop our bases and solve for x. Right, that's 1/10. So we're rewriting 1/10, that's 10 to the negative 1.
Then you just got rid of the 10.
Right, that's so, and we did that so that we would have the same bases, and then it's raised to all the jump. Stay with me, we'll look at another example. Maybe it's a little more straightforward. So in this case, we were able to do a little bit of work and get the same base, and then we could solve for x here. I mean, if we solve all that out, x would equal, I've got it written down, 1. Let's look at this other example, letter B. I'll change colors. We have 2 to the x equals 7. Now, on the last one, someone mentioned that we could log both sides to bring the exponent down, right? Which we could have done, but and this one was more difficult than probably we would like to get the same base, but since we were able to get the same base, we didn't bring in a logarithm. In this case, with letter B, are we able to get the same base? Can we rewrite 7 in a way so that it's 2 to the something? No, we can't. So this is where we would need to use our logarithm properties. So if we need to get this x out of the exponent, what would we need to have the base be of our logarithm on both sides?
2.
Yeah, base 2.
Oh, so
Because log base 2 of 2 to the x, since we have a base and a base that are the same, they undo each other, and that x comes out of the exponent.
So we don't have to simplify that. That's the answer.
It might tell you round your answer to the nearest hundredth or something like that.
Yeah.
But if it doesn't, then that would be great. even if you look at a problem like this and you think, geesh, right now I could not do that on my own, do you see how we are using our exponent rules and our logarithm rules that we've talked about? Okay. That would be the goal in this. So, does anybody, before we get there, does anybody like chemistry class?
Me.
Really? Sweet. Does anyone know Newton's law of cooling? Is that in chemistry? That might not be. That's physics? Is anybody in physics class?
I dropped it.
Oh, that's okay. I thought this problem would be sweet
Something like that.
for anybody in physics class. So here's a realistic story problem. You are cooking an Ethiopian stew. When you take it off the stove, its temperature is 212 degrees. The room temperature is 70 degrees. And the cooling rate of stew is 0.046. So here's your application for anyone that wonders, when am I ever going to use logarithms? Here it is. How long will it take to cool the stew to a serving temperature of 100 degrees? Because you don't want to burn your tongue, right? That's the worst. So, of course, you would use Newton's law of cooling, which is given to us right here. I thought you guys probably would already have it memorized, but just in case I put it on a slide. So if we use Newton's law of cooling, we can plug each of these numbers in somewhere to our equation here, correct? Right? So why don't we go ahead, are you guys taking notes and writing things down? You probably should be writing a few things down. Good. Why don't you go ahead and plug each of those numbers in, and we'll see where we're at. So we've got 100 equals 212 minus 70. Plus, I think that's what our setup would be. Do we have our setup? Now, let's isolate this term because it's what has the variable in it. So first we could subtract 70 from both sides. And what's 212 minus 70 in our parentheses? 142?
Yeah.
Good? That we would simplify. We can do this so far. What would our next step to simplify be? We'll need to do that eventually. First, I think we can divide 142 over. I'm just going to leave this as a fraction for right now. Now what would we do, Faith? Yeah, if we can ln both sides, then we can bring that exponent down. Ln and e undo each other, so we can bring that exponent down. And our last step would be to what? Someone in the back row. You've been quiet. Nope. Back row. What would our last step be to solve for t? Anybody in the back row?
Yeah.
Last step to solve for t. We get t by itself. We need to figure out this negative 0.046. We need to divide it. Yeah, there we go.
Good job.
So t equals, and you can plug this in your calculator to get a decimal, but ln 130 over 1 42 divided by negative. Put too much. Yeah, I mean, you could simplify the fraction if you wanted to. It wouldn't really make a huge difference. And what should we get? 33.8? Let's see. Yeah, or leave it outside, or leave it to cool. So, now you know that when you're cooking Ethiopian stew, if it's 112 degrees and the room you're in is exactly 70 degrees, it would take 33.8 minutes for it to cool to a good eating temperature. Yes.
How often do you cook
Once a year. Yeah, when Cubby's around. She likes to make Ethiopian salad more than Ethiopian stew. Yeah. My cousin in Ethiopia. Okay, let's keep moving. I know some of us are like, what the heck is going on? It starts out with more complicated examples, and I'd say it gets a little bit easier as we go, so stick with it. We look at letter A. Now we're trying to solve more, maybe kind of more regular equations. Since these are both inside of an ln, what can we do? We can just drop our ln on each side. Because they're both being ln. Yeah. I mean, think about it. If you had an equation that had a negative sign, it was like this, and you had a negative sign out front of each side, you could just drop the negative and solve. I mean, an ln isn't just a negative sign, right? Ln natural log is actually an operation, but it's the same thing to each side, so we can just cross it right out. And x would equal, what do you say, Ryan? Well, I agree. Now, where we have to be careful, and what caught a lot of people on our last test, is checking our answers. So, in this case, we'd have to plug x back in and check it to make sure it works. Most likely, when we only have one answer and we get x equals 4, then it's probably going to work. We're probably going to be okay if we did all our steps correctly. Where things, what thing? Yeah. Yeah. ln 4 times 4 is 16. Minus 7 would be 9. Yeah, ln of 9, ln of 9. So we're in good shape. That's okay. Where we have to be a little more careful is when we have something where x equals 4 and x equals negative 2, where we get two answers. That's where a lot of times only one answer will work. We have to be a little more careful. You could, if you wanted to, yeah. Based on the rules that we know, how could we solve this? Well, that is the last word, but first we need this. No. This to the this equals that. 2 to the 3. This to the this equals that. It's that easy. Like we talked about earlier, when we have a logarithm, a lot of times our goal is going to be to get rid of that logarithm somehow. Okay? This. Let's do this. 2 to this equals that. 2 to the 3 equals that. Can we solve this? X equals what? I agree. What questions do we have so far? again, as we go through these, I understand that you might look at it and be like, I have no clue how I would begin to solve it. I totally get that. But what my goal is that as I go through these steps, that you see where those steps are coming from. Because we have talked about all of these rules. And then once we get on the worksheet and a little more practice tomorrow, then that's where, I'd like to take a little more ownership of it and come up with some ideas. Why don't you guys try this one on your own? Take about a minute. Try this one on your own. Not for this one. Well, not yet. Actually, eventually, yeah. But that's not your first step. Thank you.
Hey, it's fun time.
We might actually go. No, we'll be done just after phone time starts. So you only get 4 minutes or 3 minutes of phone time. Yeah, but it doesn't really change a whole lot. It's okay. It's fine. Chase me away. It's all good. He probably just wants to tell you good games from yesterday. Hey, try this problem.
Sorry. I'm trying it really hard.
No, we can get rid of them. Here. We could probably what I'd like to see you do. What is this log base? Now, if we didn't have our calculator with us to graph, how could we solve this? Quadratic formula. Should we sing the song just for fun? Really loud so Mrs. Stone can hear it?
What's that?
Well, yes, Caleb. Yes. I'm sorry. B squared minus 4ac, B squared minus 4ac, all the way, all the way. I'm actually coming back. Now, if we could, I'm joking, but I was joking, but now I'm not. We could do the quadratic formula to solve this, right? We also could just plug it into our graph and see where it crosses the x-axis. If we did either of those strategies, we would get x equals 10 and negative 5. Guess what we would have to do after that? Check it. And when we check it, we would want to plug, into this original equation, we would want to plug 10 in and negative 5. Left half of the room. Why don't you please plug 10 into that original equation? Split down the middle at Grace and over, right hand of the room. Why don't you check negative 5?
Yeah.
It works.
What does?
Both of them.
You already tried both of them?
Yeah. They work.
Log negative 10 plus log negative 10 equals 2.
You're checking those two numbers, of course, and they both work.
Both work? Cole checked them both, so I guess you are nailing it. Good job.
I was overachieving.
Yeah, no big deal.
I felt a little bit eager to go from those two.
When I think of going at this, that's exactly what I'm doing. We good? What? We have questions right now, or are we just surviving?
We're surviving. We're thriving.
Well, I wouldn't use the word thriving to describe us at this point, but that's okay. We'll get there tomorrow. Okay. It's better than the negative. Okay, two more examples. Both of them have to do with inequalities. But it's okay. But we're using all the same rules that we've talked about. We don't even have to switch to inequality signs, so it's all good.
Remember, math is a wonderful thing.
Oh, I just don't have anywhere to do that.
How? Step one, we need to get this x out of the exponent. How do we do that?
Square root.
No. Base what?
This to the that equals that.
Base log.
I didn't leave myself enough room. But we need to log both sides, so. So the log base 3 of 3 undo each other, and x comes out of the exponent.
Wait, can we actually do the square root of x? No. We could not. That you check. I'm not sure how you're gonna do that, but go for it.
Back row, how we doing? Well, I can hear the front row very clearly, so it's all good. Middle row? Rhea? How we doing?
All right, that's what I figured. You're lying to me.
Aiden? You okay? Vincent? Where are we at? We good? Okay. Last example. And then you guys can put this in the storage file until tomorrow. How are we going to get rid of this logarithm? No, we don't get rid of a logarithm by logging both sides. Not quite. This is that equals this. Oh, not equals.
It doesn't look as bad as it should. This needs another line. Wait, start it up.
All right, what do we think? It is. That was a long time, but it was very conversational, so it went really quick, right? Yeah.
I don't know, it took a long day to get over.